Hello everyone, welcome back to our channel. So in this video, we are going to simplify some more algebraic fractions. So our first question is something like this. We have m plus n divided by m minus n plus m minus n divided by m plus n. So before simplifying this fraction, let's look at a simplified version of this type of question. Let's say we have a divided by b plus c divided by d. Then what we do in this case is first we take the LCM of the denominators. And the LCM of the denominators, when they are completely different, like in this case, it's b and d, is the multiplication of those denominators. So the LCM is going to be b times d. And whenever the LCM is the multiplication of the denominators, when you write the numerators, what you do is you multiply the numerator with the opposite denominator. So you cross multiply them, okay? So we have a times d is ad plus b times c is bc. And that's it. So when you have different denominators, what you do is you write the LCM, which is the multiplication of those two denominators. And when you are writing the upper part of the fraction, you cross multiply these numerators with the corresponding denominators. And you get your answer AD plus BC. And that's what we are going to do to simplify our question. Equals to, first what we have to do is we have to take the LCM of the denominators. Since this is m minus n and this is m plus n, the LCM is going to be m minus n times m plus n. Now when you write the numerators, the above part of the fraction, you have to cross multiply them, right? So we multiply m plus n with m plus n. We are going to get m plus n whole square plus we have m minus n times m minus n is m minus n whole square. Now we just put the formula of a plus b whole square and a minus b whole square here. So we have m plus n whole square is m square plus 2mn plus n square, and then m minus n whole square is m square minus 2mn plus n square divided by we have m minus n and m plus n equals to, we can just cancel this plus 2mn and minus 2mn, right? Positive and negative, they cancel each other out. And then we have m square plus m square is 2m square plus n square plus n square is 2n square divided by we have m minus n and then m plus n is equal to 2 bracket m square plus n square. We are just taking 2 as common here, divided by m minus n, m plus n. And then we have simplified our first algebraic fraction. Okay, so let's do another one. So we have 3 divided by x square minus 4 plus 1 divided by x minus 2 whole square. So equals to, so we have 3 divided by x square minus 4 is the square of 2. So we can just write it as 2 square. And I'm just going to copy this down. Okay, so we have x minus 2 whole square equals to 3 divided by, now we are going to use the formula of a square minus b square, which is a plus b, a minus b. So it's going to be x plus 2 and x minus 2. I'm just using the formula of a square minus b square over here. Plus 1 divided by x minus 2 whole square can be written as x minus 2 and another x minus 2. Okay, so 2x minus 2 is x minus 2 whole square. Now, how do we take LCM here? That's the important thing. Again, let's look at an example here. Let's say we have a divided by bc plus d divided by ce. Now, in this case, when we take the LCM, what we do is first we write the common terms, okay, in the denominator. So we have c as common, so we write the c. And then we write the remaining terms, which is b and then e. So we can write b and e there, and that's our LCM. Now, when writing the upper part of the fraction, what we do is we multiply this a, right, with e. Now, the question is why? Because in the denominator, we have BC, but in the LCM, we also have E. So we have to multiply this denominator with E to make it similar to our LCM. That's why we have to multiply the numerator also with E. So we are going to get EE here. The denominator is already BCE, so we don't need to write this part, okay? Similarly, in this case, in our D divided by CE, we have CE, but B is absent there, so we have to multiply this denominator with B. Similarly, we have to multiply this numerator with also B. So what we are going to get here is DB, and again, we don't need to write this denominator because we have already written the common denominator as BCE. And that's how you write the upper part of the fraction. Now let's do the same thing in our question. So we have x minus 2, which is same in both the denominators. So we write x minus 2 first. And then we write the remaining things. So we have x plus 2 over here. So I'm going to write that x plus 2. And over here we have another x minus 2, right? So I have to write that x minus 2 as well. Now, while writing the numerator part, right? So what do we multiply this 3 with? We multiply this 3 with the term which is absent in the denominator over here, but it is present in our LCM. So we have x plus 2 and x minus 2 in the denominator with our 3, but x minus 2 is absent, so we have to multiply that 3 with x minus 2. And then we copy our plus over here. We have our 1. Again, we have to multiply this 1 with the term that is absent in the denominator here, but which is present in the denominator of our LCM. So in our LCM, we have denominator x plus 2, x minus 2, x minus 2. Here we have only 2 x minus 2s. So this is present, this is also present, but this x plus 2 is absent. So we have to multiply that 1 with x plus 2, the term that is absent in the denominator but present in the LCM. Okay? Now we just multiply it. So we have 3 times x is 3x, minus 3 times 2 is 6, plus 1 times x is x, 1 times 2 is 2. Divided by, we have our x plus 2, x minus 2 whole square. Okay, so there are 2x minus 2. I'm just writing it as x minus 2 whole square equals to, we have 3x plus x is 4x. So I'm going to write that as 4x minus 6 plus 2 is minus 4. Divided by, again, we have x plus 2, x minus 2 whole square. Now, we can take 4 as common. So we have x minus 1 remaining here, divided by x plus 2 and x minus 2 whole square. And done. We have simplified this question as well. Now let's look at another one. So let's say we have a cube plus b cube divided by a square minus ab plus b square plus a cube minus b cube divided by a square plus ab plus b square. So in this question, first we are just going to put the formula of a cube plus b cube, which is a plus b, and then we have a square minus ab plus b square divided by, we have a square minus ab plus b square in the denominator. I'm going to put bracket over here as well, plus we have a cube minus b cube. So the formula of a cube minus b cube is a minus b, a square plus ab plus b square divided by, again, we have a square plus ab plus b square. Now here what we can do is we can cancel these, right, since they are same. Here also we can cancel these two terms. And then we get our a plus b plus a minus b. You can put the brackets over here or you can remove them. It's the same thing. So if you do put the brackets, you have to open them in the next step. So a plus b plus a minus b. Again, these two b's get cancelled, plus b minus b. And we have our answer, a plus a is 2a. And done. So that's how we can simplify these type of algebraic fractions. If you found this video helpful, please like it and subscribe to our channel for future paths videos. Thank you.